Hi, my name is Richard John, and this is my project, Application of Random Forest Regression on Inflation Prediction. Now, as we all know, inflation has reached quite large levels ever since COVID-19, which has severely stretched the average American citizen quite thin, especially financially. Thus, inflation affects both businesses and consumers, and predicting inflation can be key towards making well-informed decisions in the future. Now, deep learning in our situation, when it comes to predicting inflation, can be advantageous due to the fact that inflation data typically has a nonlinear and non-stationary form. Thus, our project intends to examine the performance of a random forest regression model when it comes to predicting inflation. So, when we collect data for this project, I used either the U.S. Bureau of Labor Statistics or the Federal Bank of St. Louis. Now, this data is open to the public, so as long as you have internet, you should be able to access them. Now, with the standardization of our data sets, we do this in order to make sure they all start at the same date. Since many of the data sets, they didn't start at January of 2001, so we had to standardize them to that. Next, we scaled our data sets, makes it much more easier for our machine learning model to train on them. And then we split them into 240 for the train set and 45 data points for the test set. So now we have our linear regression model. This serves as the baseline in comparison to our random forest regression. The main thing we want to focus on is this section, as this is the section where where the regression model starts to actually diverge. With the predicted data getting the trend of the actual core CPI, but still being quite distant. And let's take notice of our MSE, which we will use to compare to our random forest regression model later on. So this is our random forest regression model. In order to use this, you're going to have to import this from scikit-learn. Now, an estimator is here, which is 200 represents the amount of decision trees. The more decision trees, the better the model is at learning the ins and outs of the data. So the result first attempt, our mean squared error is 0.0783 compared to our linear regression model, does not fare well. We do this again, but this time, well, actually, let's look at this plateau here. We do this again, this time was 20,000. Still does not fare as well. And if you notice, this one has a 0.0096. This was when I used it to predict the values for the trained data. The data was trained on. If you look at it like this, we know that our model is overfitting since the predicted data for the validation data is quite higher in comparison to our trained data. And this is the results of our second attempt. So as to conclude, our random forest regression model fared quite worse than a linear regression model. The random forest regression model also appears to be overfitting on our data. And the average random forest regression has a MSE of 0.01923, as found by the K-fold validation with 5 folds. So improvements we can alter the structure of the random forest regression model, and we can also add much more high quality data to account for the numerous factors that this project didn't consider. And inflation is definitely impacted by a large amount of features. Thank you for listening.